All right, this I can statement says I can create a velocity versus time graph to describe the acceleration of an object. Let's look at an example here. So we have a table, probably of a car accelerating, time in seconds, followed by the speed. And as you can see, the speed seems to be increasing every second, which of course shows acceleration. So let's graph it. Let's go ahead and put speed over on the y-axis. Of course, that's in miles per hour. And then time in seconds on the x-axis. Maybe we can go up here by every third. So we have 10, 20, 30, this will be 40, and this will be 50. Okay, and it could go up from there. And then along the time axis, we'll label it maybe every 2. And this table goes to 8. That's what I'll do here. All right, let's graph the first point, which is 1, 6. I'm over here at 1, and I go up to about 6, which probably is around this vicinity here. All right, and then the next time is 2, which goes up to 12. Then I have 3, which goes up to 18. 4 goes to 24, right about there. 5 goes to 30. 6 goes to 36. All right, I probably don't have to graph the rest of it because as you can see, we have a straight line here. Let's assume for a second that the origin is at 0 because obviously the car was not moving at 0 seconds. And let's connect the dots. And this would be a speed versus time graph. You would graph a velocity versus time graph the same way. And of course, this slope shows acceleration. I could even figure out what the slope is by doing rise over run. In this case, I could do, let's see here, I would rise 6, and I went over 1. Because this is a line, I can assume the slope is the same the entire way through here. So the slope is 6 over 1, or in this case, the object is increasing speed 6 miles an hour per second, and that would be the acceleration.